All right, so here is an example of how we can visually see how the Pythagorean theorem works. So if I look on the right side here, here is my right triangle, right? Here's my triangle. We know it's a right triangle because, again, here's my right angle, that little square that tells me that this is a right angle, which means that angle right there is 90 degrees. And so what I'm going to do is I'm going to highlight first each side of our triangle. So here, I'll make that one red. I'll make this one down here green, and then I'll make this one over here blue. All right, now, if you remember, the first thing that we want to do is we want to identify which side of this triangle is our hypotenuse. So again, to do that, we first want to locate that right angle, and then we want to draw an arrow that points away from that right angle, and that arrow will then point to our hypotenuse. So if I see this long side right here that I labeled blue, that's my hypotenuse. All right, and we know that the equation for the Pythagorean theorem is a squared plus b squared equals c squared. All right. And so remember, anytime I'm squaring a number, I'm taking that number and I'm multiplying it by itself, okay? And what we create when we do that is actual squares. So if I look on the edge or at the end of each side of my triangle, I've got these squares, right? So here's my hypotenuse, that long square. We'll make that one blue. The first red side on the left, we create this red square. And then we've got this green square down here. All right. So if I look down here, well, first let's read what it says. It says the sum in a right triangle, the sum of the areas of the squares on the legs, okay, is equal to or is the same as the area of the square on the hypotenuse. And then they've got our equation down here. So a squared, oops, let me make that a different color so you can see it better. So we've got a squared plus b squared equals c squared. All right, and they've got 3 squared plus 4 squared equals 5 squared. And how they got those numbers, again, they just counted the units for each side. So if I look here, if I'm looking at the red side, I've got 1, 2, 3. So that's 3 units, right? If I go to my other leg, which is green, all right, and I count these units, 1, 2, 3, I've got 4, right? And then if I go to my hypotenuse, or the side that is opposite my right angle, I've got 1, 2, 3, 4, 5 units there. So that's 5, right? And we know that in our equation, we need to square each side. So 3 squared plus 4 squared equals 5 squared. And so if I do that in my calculator, so 3 squared is the same as 3 times 3, I get 9. 4 squared is the same as 4 times 4, we get 16. And 5 squared, which is the same as 5 times 5, gives us 25. So then that leaves us with 9 plus 16 equals 25. And if I continue that, if I add 9 plus 16, we get 25, which is in fact the same or equal to 25, which tells us this is in fact a right triangle. And if I look here, 3 squared, which gave us 9. Well, if I count all of these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, I get 9, right? So that's the same as 3 squared, okay? Same thing here. The side that we labeled green, 4, 1, 2, 3, 4. Well, if I square that or multiply it by itself, I create a 4 by 4 square, which gives me 16 total squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Which was the same as 4 squared. So anytime we're talking about area, we're talking about square units, right? Square units. So 3 squared, 4 squared, and the same with our hypotenuse. So if I were to count all of those squares, I would get 25, which is the same as 5 squared. All right. Now, if I add all of these squares plus all of these squares, so those are my legs, right? So if I add the 2 squares that represent my legs, which were 4 squared and 3 squared, or 9 and 16, if I add them, I get the same amount of squares that are in my hypotenuse, or 5 squared, which would give me 25 total squares. So again, if I add the total squares for my legs, I get the total squares in my hypotenuse.